Now let's look at our signal coming out of our circuit here. To do that, we're going to hook it up to our circuit. Now we could actually hook it up to our integrated circuit chip, specifically to pin 2 of the 555 timer chip. But instead of doing that, the instructions say to connect it to pin 40 and 41, pins 41 and 40. And the reason why is that those are actually already connected to where we need to go. If you run a trace back, 40 goes to ground. So I'll connect up the ground clip on the oscilloscope to 40, to spring number 40. And the 41 already has a wire running over and connects to pin 2. So it's already set up there. Okay, now I look at my oscilloscope and I see I have a signal on there, but I see that it's racing out of control. It's not stable, so I'm going to use the trigger control here to steady the signal up so it doesn't move across the screen. There, like that. The other thing I'm going to do, I'm going to move it down on the screen here using the position control knob, and I'm going to rest it on that line right there just so I can get a good reference to measure it. Okay, so the first thing I'm going to do is I'm going to look at that, what kind of wave that is. What kind of wave would you call that?
Sawtooth?
Yeah, I'd call it a sawtooth. It looks like the teeth on a saw, doesn't it? Yeah, or you could call it a triangle wave, but a sawtooth is really more what it is. It's more like the one here on the screen. You have sine wave, square wave, triangle wave, and sawtooth. And it's definitely more of a sawtooth shape to that wave. Oops, I knocked it off. I connect it back up here. Okay, now let's measure some stuff about this wave. We want to measure the peak to peak like we did on the other one. So I'm going to do that using the controls here. Now I have my voltage set at 1 volt. I could make the picture bigger, but up and down, by changing that to 0.5 volts peak to peak. So I did that. And I'm going to change the triggering on it too here so it's got a nice steady picture. By doing that, I made the picture bigger, which just makes it easier to measure. Now I could go ahead and rest it on the bottom line. That'd be okay too. Now what I really want to measure is from the very bottom to the very top. To make that easier, it's sometimes nice to slide the picture sideways a little bit, and I made the peak go right in the center here where I have this line going up and down with the little graticule marks. They call them graticule marks. That divides up the divisions into smaller pieces. It divides up each division into 5 little pieces. So I can count going up here. I've got 1, 2, 3, 4 squares, and about 2 more little graticule marks. So that would be 2/5, or 4/10, I would say. So we've really got about 4.4 divisions going up and down on that. So now we'll calculate that. We'll write that down, that we've got 4.4 divisions, and we're going to multiply that by 0.5. It's what our scope is set on 0.5 volts per division. So that gives us 2.2 volts, and that would be peak to peak voltage. Does that make sense? So our voltage difference from the very bottom of our wave to the very top is 2.2 volts. And if we go by that, then since peak voltage is equal to